Hello, my name is Alex Bednar, and this is the screencast for my final project for Geography 167. I've always loved prehistoric animals, and dinosaurs in particular, so I wanted to do something about this in my final project. I thought it would be interesting to map out fossil location sites within the lower 48 United States. That is what I set out to do. I thought this would educate people on our country's geologic history, as well as show people where they would be most likely to encounter certain fossils from certain regions. If you want to find a creature from the Devonian, my maps would have you covered. To begin, most of the data that I received came from the website the Paleobiology Database. This allowed me to download data of fossil collection sites in the United States. I would get the latitude and longitude data, download this as a CSV file, which I would then place into ArcGIS. We have here a map of all the Cretaceous fossil sites in the lower 48 United States. I overlaid that over a map of the geophysical regions of the United States, as well as each individual states. I did this for all 12 geologic eras of the Phaerozoic, the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, Paleogene, Neogene, and the Quaternary. Along with this data on where specific fossil sites can be found, I also took data on how many fossils were found per state and how dense fossil finds are within each state. My final project is here. It begins with the two maps that include the total fossil collection sites by U.S. contiguous states, as well as the fossil collection sites per square kilometer within the contiguous United States. As you can see, states like Texas and New York have quite a lot of fossils, as well as a lot of fossil density. But when you include density, you can see that Wyoming is a denser fossil region than Texas, although Texas has more fossils than this. However, I wanted to go more specific, because as mentioned before, I tried to map out fossil sites from each region. The second portion of my project is of the Paleozoic era. The Paleozoic era encompasses the Cambrian to the Permian. This is essentially almost the entire history of most complex life. It starts in the Cambrian explosion, which was a large explosion of biodiversity in Earth's history, and ends in the Permian extinction, which was the greatest mass extinction in the history of our planet. As I mentioned before, each of the regions are mapped out by color on here. Each dot represents a fossil collection site with latitude and longitude data. The times frames of all the regions are on the maps, as well as a legend that includes the U.S. physiogeographic regions. The Mesozoic and Cenozoic eras, which occur after the Paleozoic, are also mapped. The Mesozoic is the era of the dinosaurs, and it begins with the first dinosaurs in the Triassic period and ends with the dinosaurs' extinction 65 million years ago in the Cretaceous age. The Cenozoic era is essentially the extinction of the dinosaurs to our present time period. So this was the core of my project here. I also have a works cited page that includes the Paleobiology Database, as well as University of California, Berkeley Department of Paleontology site, where I received much of my information that I use in the little information bubbles that are on each of the portions of my maps. And I also include pictures of some of the more well-known animals from each area. So that is the bulk of my project. In terms of kind of technological aspects, how I did things, in order to get data on exactly how many fossils are within these regions, I queried by my state file and selected all the fossil locations within that site to get the total number within Wyoming, for example. Then I would take the square kilometers of Wyoming and divide the total number of fossils by that to attain Wyoming's fossil density. So I hope you enjoyed this project, and I hope you enjoy reading it. Thank you for a great class.